almost always is. I turned around from my desk to answer a question the other day, and this is what I saw. I'm not sure exactly how it came about, but it was just kind of a typical day in the Math Center. But I asked her if I could use her pictures. So it'll come up in just a minute. All right, while we're waiting for that, let's look at some Delta Math questions. Let me go to yours, sample student page. All right, Algebra 2. On graphing lines from equations, we'll start there. I'll do one and then I'll let you ask. Oh, there it is. So it reminded me of Cindy Lou Who. I also could have kind of used trolls, but anyway, look at her hair. I don't know how she did
Jenny
that.
Humphrey from Gossip Girl.
Oh, is it? Okay.
Wow.
Wow.
Yeah. You guys didn't know that? No.
Okay. So, girls, I want to really harp on this. I wish one of my teachers had done this in Algebra 2. It would have helped me a whole lot in pre-cal and calculus if they had just kept saying what I'm about to say to you. A slope is a rate, okay? Like a temperature might go up 1 degree every 4 hours. Whereas sometimes it goes up really fast, like in the summer. You might wake up and it's 75 degrees in the morning and it feels kind of decent. And then by noon it's already 95 degrees because it's gone up like 6 degrees an hour or something like that. It's really a rate, okay? Now reading this graph from left to right, raise your hand. Let's just don't answer because you're all animated today. Raise your hand if you know if this graph should be going up or down. Just raise your hand. Gabby, saw your hand first.
Should be going up.
Up from left to right because it's a positive rate of change, positive slope. Okay, so should it be going up slowly or really, really fast? Raise your hand. Grazia?
It should go, kind of slowly.
Kind of slow. If that had been like a 4 or a 5, it'd be really steeper. It would be a steeper hill, okay? And it really is slope, like if you ski, all right? I'm going to put my y-intercept at 2. That'll be something right after Christmas when we have quizzes on lines and then eventually a test on linear functions. That'll be a word you need to know, the y-intercept. And then I'm going to drag my line up 1 and over 2. And then I'm going to click Submit. And let's see what the next one is. All right, new problem. All right, it's kind of the same thing, so we'll give up and go to another problem. Okay, this one's going to go down, really, again, kind of slowly because it's a fraction less than 1. My y-intercept is -2. A negative rate of change, it should be going down from left to right. And so if you were skiing, you'd be up here and you go like this, okay? All right, so then I'm going to go down 2 from here, 1, 2, and I'm going to go 1, 2, 3, and make sure that I've gone down 2 over 3. And that's what we call my rise over run. Okay? All right, questions. Victoria, you had questions.
I said
For the next one?
Yeah, for writing equations.
Okay, any questions on the graphing part? Obviously, by quiz and test time, I should be able to give you this equation, and you should be able to draw the graph on your own. You go down 2, and then down 2 and over 3, make another dot, and connect the dots, which I think you've probably all done before. All right, on the other assignment, writing equations of lines. All right, so I'll do this one, then I'll take questions. My y-intercept here is -1. And in front of that, I want to put my slope with an x in it. So in front of that, I'm going to go from another point. They gave me 2 dots. So I'm going to go down 1 and over 1, 2, 3. It looks like 5. So I'm going to have -1/5. Oh, I'm not typing. -1/5. And that ought to get it. So you need the y equals it. Oh. Okay, well that wasn't very good. Oh, I need the y equals. Y'all have learned all the tricks. Okay. Yeah, sorry about that. Okay, so until you learn what Delta Math wants you to say. All right, questions on writing equations. Victoire?
Oh, yeah. I wanted to know how you better identify when you're supposed to have it, like when the X is negative or not. Because
You mean the slope in front of the
slope,
X?
Yeah,
Uh-huh.
in front of the X is negative.
This slope's going to be positive.
Because upward, even though it's in the negative range.
Even though, all of our lines go into some sort of negative when they're diagonal. Like the ones that are going like this will go into the negatives. Yeah, I certainly can go up from the negatives into the positives.
Okay.
But Victor, great question. It could be way down here.
Okay.
And the slope's still going up.
Okay.
This is interesting though. Watch this right here. This is going up 1 and over 2.
Yeah.
That's positive 1 and positive 2.
Yeah.
What if you counted from here? That's going down 1 and back 2.
Yeah.
So
What is negative 1 over negative 2?
100.
It's still a positive slope, isn't it?
Right.
Okay.
That's what
I mean, I wouldn't do that. I would normally count forward.
Forward, yes.
Okay. So another question?
can I run the bathroom?
Yeah.
I can wait.
There's not going to be a good time to go, so you can go now. It's just bad a time as any. So, I'm going to give out packets, and we're going to be doing some new stuff. So you may want to go now while I'm passing out packets. We'll just put one on your desk. Hey, girls. Susan?
Oh, I have a question. So, how do you identify where to calculate the rise and the run?
Right now, we have the luxury of these cute little dots on here.
Yeah.
A lot of times, Susan, probably what you've already realized is there's just going to be a line
Yeah.
going from somewhere to somewhere, and you're like, nobody's giving you big blobs to look at.
Yeah.
Right now, you and I would look at these dots and count from like this dot to this dot, okay? If those dots aren't there, then I will have to give you points or something to count by, and we'll work on that some today. But if you just had a line that was going like this, without like blobs on it, without dots on it,
I usually add them.
you still would want to try to find the corners.
Yeah.
Okay?
Okay,
Is
but
that what you were going to say, Marie?
yeah.
Go ahead.
But also, when I was doing Delta Math last night, I saw that it was like when I was calculating the rise and the run, I would put it in the part that's kind of green, but then it would calculate the rise and the run in a different part on the line. If that makes sense.
Oh, that won't matter. I mean, you should still get the answer right if you do it from here to here, and Delta Math does it from here to here.
Yeah, exactly. Does that
They
matter?
just have to grab 2 points to explain it to you.
Oh, okay. So
Okay?
Okay.
All right? All right, so, so Victoire, I think I got your question answered. And good question about the dots. Susan and Tess will have to have some way to where you know where the dots are. Like if it's on graph paper and I don't put physical points where you can see them, you can do what Marie said and she can find right where it crosses and make her own dots. We'll practice on that. But lots of times I'll label the points or give you the points you'll see. Okay? And listen to what Susan said. I could have used these 2 points, okay? Margot could have used these 2 points. Yana could have used these 2 points. Marie could have used these 2 points. Eliza could have used these 2 points. And Susan could have used those 2 points. They all have the same slope, okay? So I'm so glad you brought that up. That's going to happen in class sometimes where I grab a different 2 points than you do, but they're all on the same line, so they should have the same slope. Because I'll draw one for you like this, which we won't be able to see on the slides. But if I put a dot here, and then I go down 1 and over 3, and then if I go from there, down 1 and over 3, down 1 and over 3. Do you see how they definitely are going to line up and create a line? That's the whole point. It's only a line if it has the same slope the entire time. Okay? Marie, comment? Did you have your email? Okay.
This is it.
Yeah.
I was gonna say before I feel like I was doing it for the opposite from each side. If it was -6, then I'd go to the +6 and then I'd count it. But then I kind of realized that the dots were the same. So you can use any
Right. So you're okay?
Yeah.
You got it? All right. Okay. Now, if, let me get the slides, let's see. Okay, so, like I said, a slope is all about a rate of change. When we say rise over run, and you're going to have sheets that say this, you don't have to take notes. In fact, let me go ahead and pass out the sheets. And miraculously, they also have the date on them. So it gives you some facts that you just want to save. All about lines is on the front. Okay? I won't worry too much about it until I get to it. But this way you have it in your hand to take notes on.
Oh, thanks for putting the date by
I know, like I said, it's a miracle.
I mean, I normally put the dates on mine, so.
You need a pen?
This is not.
I could use an extra.
The extra paper? So I got one that's the next. Okay, if I go from, and you're just sitting watching right now. Girls, you can maybe just write your name on it real quickly and then just wait for a minute, okay? And then I'll point out where I am on the sheet, okay? If an hour into my trip, I am 50 miles from New York City. And the 2 hours into my trip, let's say I'm 110 miles from New York City. So here I am driving. I'm not trying to draw a graph right now. I'm just driving somewhere upstate, okay? So I guess I should go up. Right now I'm not drawing like a line. I'm just drawing like a map of where I'm going, okay? So say I'm going from here to here, all right? And let's say I've got to get 200 miles on my trip. And so I'm like maybe want to go skiing or something, okay? So I'm going to go to Vermont. I don't even know if Vermont's over there. I'm not very good at geography, but let's pretend. And so I need to drive 200 miles. Now, an hour into my trip, I was 50 miles from my apartment. 2 hours into my trip, I was 110 miles. So can y'all see if this is 50 miles out and this is 110 miles out, I still have 90 miles to go. I'm about halfway, a little bit more. Y'all know how you ask your parents, when are we going to get there kind of thing. Or you look at your watch for a 2 or 3 hour trip, or your phone. You probably don't look at your watch, but you know, you realize, oh my gosh, I've only been in the car for 40 minutes and I got it. Y'all know that feeling, okay? What if you wanted to tell your parent to drive faster so you could hurry up and get there, okay? They probably don't want you to suggest that, first of all. But they might also say, I'm going the speed limit. I don't want to get a ticket. I don't know if y'all have these conversations because you may not be in cars very much. You may just be on the train. But anyway, does anybody know I can figure out how fast my parent is driving if I give you these two facts? Gracia?
Well, I think miles per hour.
We'll end up, this is 1 hour into my trip. I'm 50 miles from home.
Yeah.
2 hours into my trip, I've gotten at least 110 miles an hour from my home.
Well, you mean what the pattern is?
No, just how fast am I driving?
One mph.
Huh?
I mean, 50 mph.
No, I'm 50 miles from my house. You're right, though. During the first hour, I drove 50 miles an hour. But during the second hour, was I going 110 miles an hour? Let's hope not, first of all. Okay. Sarah, what were you going to say?
Is the formula like speed with distance over time?
Okay, forget formulas for a minute, but probably. What'd you say?
I like distance over time.
Okay. Rate is distance over time. Let's run with that. All right, so distance over time. And these are the only two facts you have. All right, Rebecca?
55 miles
No. Okay, I think you averaged them maybe.
Wait, what's the distance again?
Oh, you know, that's an interesting concept. There is a way that you could say 55 miles an hour, Rebecca. But not if you're only looking at this point. But if you knew this also, hey, can you tell that your parent did speed up?
Yes.
If your parent did not speed up, how far would you be during the second hour?
100.
100. So your parent did go faster than they were at first. Okay? Hey girls, if you were 50 miles from your apartment in 1 hour, your parent's driving 50 miles an hour during the first hour. Okay?
So it's different.
They're going faster now.
Okay.
All right, so here's my question. How much distance did they cover during this time? 60. Okay? So they went 60 miles during this time. They went 60 miles an hour. Let's go back to what Grazia said. How did I get MPH? What's 110 minus 50, and these are both in miles? I went 60 miles. I just subtracted it in my head, common sense. And how much time did that take me? 2 hours minus 1 hour equals 1 hour. And so I know I went distance over time, Sarah, 60 miles per hour, which you could write miles over hours if you want to. So in light of all of the answers you gave me, this is very interesting. During the first hour, your parent drove 50 miles in 1 hour. And so they went 50 miles per hour. Okay? Then they went up to 60 miles an hour during the next hour. So Rebecca, it does make sense that on the average of the entire trip, they did go 55 miles an hour. Do you see the average right there? Between 50 and 60? So let me draw a little picture of this. Here's our trip. During the first hour, we went 50 miles an hour because that's all I had. During this hour was what I was asking for. Between 1 hour and 2 hours, how fast were we going? Well, I covered 60 miles in 1 hour. So I was going 60 miles an hour during the second hour. All right, let me ask you another question. And don't think much about formula, okay? Let's suppose that you have a puppy, and I had a Great Dane who has since passed away because they only live about 10 years. He was 9.5 when he died. I'll give you pictures of Harley sometime, big old black Great Dane. He's so much fun.
I love
You know, when I would walk him, I would put my arms
back.
Really?
Yeah.
He was that big?
Yeah, they're
I wish
huge.
he was big.
You know what? That's a good point. I don't remember it as most how much they weighed. They're not as sturdy as a Rottweiler. They're kind of thin dogs, but not as thin as a Doberman. But I think like 160. I don't remember. I'll show you a picture later. All right, back to this. We'll let Harley be our size one day. But I remember when my husband brought home this puppy, and he had called me and said, we're going to get Clayton a Great Dane. He had been wanting one so bad, and my husband found a black Great Dane to surprise Clayton with. And so I'll bring Clayton in from basketball practice, knowing he's going to be so excited. I'll show you a picture of this one time. So Clayton's walking in the door, throwing down his backpack, and he goes into the dining room, and there's a puppy. And he picks up this puppy, and he's like so happy. And I'm kind of looking at my husband going, you got the wrong puppy. If you've ever seen Clifford the Big Red Dog, it's like that. I thought he got a black lab or something. It was the cutest little black puppy with big old ears. And I'm like, you were supposed to get a Great Dane. I think the next morning he was bigger. And then the next morning he was lots bigger. I mean, I felt like we could just sit on the couch and watch him grow. And it ended up being the right kind of puppy. But my point is, suppose that after a month, let me put numbers in. After 1 month, your puppy weighed 30 pounds, okay? And after 3 months, your puppy weighed 70 pounds, which is a bit ridiculous, but let's just work it out, okay? How fast was your puppy growing? How'd you do that?
Oh, because if you subtract 70 from 30.
So Jillian's thinking, oh my gosh, my puppy gained 40 pounds in just how long?
2 months.
2 months. And so her puppy would be like Clifford the Big Red Dog. It would have gained 20 pounds per month. Okay?
How many days are in a month?
It doesn't matter. Let's keep going. Okay, it is different for different months. Okay, girls. Do you see how I didn't write it as points? I wanted you just to naturally think about it like Jillian did. What we're doing right here, do you see how I gave you 2 points? And then Jillian used common sense to get her answer. You would go, oh my goodness, I gained 40 pounds in 2 months. Well, I hope I didn't, but my puppy did. All right? So, what we're going to do is if we have 2 points, you can find the slope. Let's go back to what the great question Susan asked. Which points do you use? And Maria was sort of answering it. Any points that you can find or that someone's given you. Back to Susan's question. We might not even be using the same points, but if they're on the same line, we ought to get the same slope. It shouldn't matter, okay? All right, so let me make up another point. Before I do it, and don't be intimidated by your friend if they answer this question. They just are a little bit further out there than I need you to be right now. Is there anybody in the room that thinks they can even name another point on this line that I'm making up? Eliza?
Is it 7 or 10?
You could go 7, not 10.
Oh wait, sorry. 11.
Yes. You could go 7, 11.
It's my birthday.
Really?
Was that July 11th? Happy birthday. Okay, don't worry about Eliza and Grazia just raise their hand. We'll get there some way, but she's got a really good sense of slope and lines, okay? All right, so what I'm saying is, how far up did you go? 4 units. And how much time did that take you?
3.
3. So your slope is 4/3, okay? Let's see if Eliza's right. How far up did she go?
4.
4. Oh, it wouldn't be 7. I didn't get the same slope. Let me show you what I was looking for. 11 was right. These, look at my wise girls, that went by 4. And so if that's the same slope, that should go by 4. And if this one went 3 units, how far across do you want to count? So that would be 8. Sorry, it's not your birthday anymore. All right, so now let's go 11 minus 4. 7 is 4. And what's 8 minus 5? 3. Now, can somebody name another one that would be on that line? All right, Margot?
11 and 15.
All right, so this is gone plus 3, plus 3. You went out 3 more. This one's going by 4, 4, 4. Okay? Now, everybody watch. I'm going to take these yellow points and subtract them. Because as Maria and Susan have got us talking about, it shouldn't matter which points you use. Eliza could use some that Evelyn wanted to use 2 more. If they're on the same line, this is happening, by the way, girls. 2, 3, 5, 7. And I don't know why I started up that high, because now I don't have room to go to 8, 11, or 11, 15. But they would line up there, okay?
Yes.
All right, now, how far did this person go? Suppose all you knew was 2 months into the puppy's life and 11 months into the puppy's life, and you didn't know anything else. You didn't know the 3rd month, the 5th month, the whatever. How much did the puppy grow from 3 to 15?
8.
How far? I mean, it went from 3 pounds, it's a little bitty dog, from 3 pounds to 15 pounds, right here.
12.
So you're like, oh my goodness, well, my puppy only gained 12 pounds in how many months?
9. Wait. 9 months.
9 months?
Yeah.
That's a 2 and an 11. 2 and 11. So in 9 months, my puppy only gained 12 pounds. Can you reduce that? What number goes into 12 and 9? 3. 3 goes into 12 4 times. 3 goes into 9.
Look at that.
Same slope. Do y'all see that?
Yes.
Okay, now look at your sheets at the bottom. And please forgive me if this may be extremely redundant
Oh.
of what you've already learned, maybe in 7th and 8th grade. But my calculus girls are still doing lines. I just think it's hard at your age to realize how incredibly important they are. So I've got to come and hit it like you don't know what you're doing or you don't remember. And then you'll just sort of forgive me if it's super boring, okay? But that way you'll have something easy for you to do. All right, in math, we call slope M. I don't know whose decision that was. Not mine, okay? Did y'all see where I am right down here in the rise over run? Okay, so I always try to make things common sense, usually to an extremely silly degree, like puppies gaining weight or your parents hurrying up and getting to Vermont or whatever, okay? But hopefully it makes sense to you now. It makes sense to go, how far did it go over run is how much time it took. Rise is up and down. Run is how long it took. All right, to get your rise, what you're going to do is subtract your y values and then subtract your x values. A lot of you probably don't like formulas, but that's kind of all we got. I have to have some way to communicate this to you. So what this is telling you is somehow, some way I'm going to give you or you're going to find your first point. Do y'all understand that subscript?
Yeah.
That means here's your first point. I don't want to do it just with one set of numbers. There's your first point. And here's your second point. Okay? So you want to see how far you went. Subtract your y's. That'll give you your rise. And then see how long it took you. That'll give you your run. So if you have months along here and a puppy growing, do you see how much weight it gained is the rise, and how long it took is the run? Rise over 3 months. Rise over run. Okay? And so you can memorize this formula, but I love the common sense approach too. See how far you went. Subtract these. And so far I've done it with speed of a car and gain and weight of a puppy. Okay? See how far those are apart. How do you see how far things are apart? You subtract them. And then see how far these are apart. You subtract them. That will give you your rise over run. Okay? So what's going to happen in class and on quizzes and worksheets is you're not always going to have a graph. You're sometimes just going to be given points. All right, so your homework for Wednesday is to make sure you arrive with this packet. Okay? All right. Huh? No, I can't give you homework for lessons in Carol's time. Yana?
So now it's like all the change of prices to look at it.
Yes. Please start me there next class. We'll write that on our sheet. It helps a lot with calculus. Very good, yeah. Yana, don't, like, you know, sometimes you got your hand up and I keep talking. Okay? Bye, girls.
Are we gonna go over slope intercept form like